Hey guys, so today we're going to be doing the UIL C test from 2022 for calculator. And my bad about the background noise. Okay, so we're just going to be doing the word and geo questions here. Okay, so number 6. You'll just add these on your calculator. Not anything too complicated here. Get the average of these for number 7. Just add them, divide by 3. $339. For number 8, we have to solve for h if ln of h equals the positive square root of this number, so we could just do e to the power of the square root of 60. We get 6.43 times 10 to the 33rd power. Or you can set up a solver here if you have a TI Nspire like this. Okay, so for number 9, rhombus. So we're just going to do base times height. So just multiply those two numbers. We'll get 7,870. Here we're given the area and we want a side, so for number 10 we're just going to do side squared equals your area. So I gotta get the square root of my area to get my side. So we'll get let me write this back. 2.59. So that's page 1. Page 2, we're on number 16. How long does it take to drive at 65 miles per hour? A distance of 45.1 miles, and we want our answer in minutes. The formula to know here is distance equals rate times time, right? So let's plug in our known values. Our distance here is 45.1 miles. That's equal to our rate of 65 miles per hour times time, and we can solve for how long that takes. So, oh wait, is my webcam blocking this? Yeah, it might be. So let me move this down. Yeah, I gotta stop doing that. So, like this, right? This is what I had written down, right? And so we can solve for time. Just do 45.1 miles divided by 65 miles per hour, which gets us 0.6938 hours. We want our answer in minutes, so we got to convert hours to minutes by multiplying by 60, because there's 60 minutes per hour. And that comes out to 41.6 minutes. So it takes 41.6 minutes to drive this distance at 65 miles per hour. Okay, number 17. So we're told fingernails, actually just right on this right side, so I don't block it. So fingernails grow at 100, and this symbol, that's a micrometer. So a micrometer, so 1 micrometer is equal to 10 to the negative 6 meters. Right, so keep this in mind. Okay, so fingernails grow at this rate daily, so this many per day. So if Andrea lost a nail that was 0.57 inches long, how long would it take to grow back? And we want our answer in days. So the way we would do this question is we're going to take this length and divide it by this rate of length per day. But we can't just divide these two numbers right now because they're not in the same units. We have micrometers as a measure of distance. We also have inches as a measure of distance. So I'll convert micrometers per day to inches per day. And so the way I'd go about doing that is I have 100 micrometers, which, like I said here in this yellow highlighted part, we're told that 1 micrometer is equal to 10 to the negative 6 meters. So these units of micrometer cancel out, and we're left with 10 to the negative 4 meters. Right? That's this per day. So 10 to the negative 4 meters per day is our rate. Now we gotta change meters. We're gonna change this to centimeters. So there are 100 centimeters in 1 meter. So these units of meters cancel out, and we're left with 10 to the negative 2nd centimeters per day as our rate. And now I can convert centimeters to inches because there are 2.54 centimeters per inch. So that's just like a conversion you gotta know. So those units cancel out. And we're left with 0.003937 inches per day as our rate. And so now we've got our rate in inches per day. We got our length in inches, so now we can divide. So we're going to do this length, which is the length of 1 fingernail, divided by our rate. And that comes out to about 145 days. Okay, so number 18. So Frank runs 1 mile in 8 minutes 25 seconds. And we want to know how long it takes him to run a lap that is 440 yards long. So let's change yards to miles so we're all in the same units. So the conversion to know here is that 1 mile is equal to 1760 yards. So memorize this conversion. So I'm going to multiply this by 1 mile per 1760 yards. Our units of yards cancel out. We're left with 440 yards is equal to 0.25 miles, so a quarter mile. So if I run, or it takes me 8 minutes and 25 seconds to run 1 mile, I can multiply this rate by our distance of a quarter mile to get my answer. And so I want to change this time to all be in minutes. So I could say 8 minutes, 25 seconds, 8 minutes, 25 seconds. That's going to be the same as 8 plus 25 over 60 minutes. Each second is 1/60th of a minute, so it's like 8 minutes and then 25/60ths of a minute added on. So this is 8 plus 25 over 60 minutes. So I'll multiply this in my calculator. And we'll get the answer of 2.10 minutes. Okay, number 19. So we have a right triangle. And so we have this side and this side, and we want to know what this angle is. So what we're going to use here is trigonometry. We're going to use SOHCAHTOA. So this is the angle we're interested in. So what side is opposite, or like what side is this one here? This side is our opposite side. It's opposite to the angle. This side is adjacent, and this side is the hypotenuse. We're only dealing with the opposite and the hypotenuse here. So that's a sine, we gotta use this ratio here. So states that the sine of theta is equal to the opposite over the hypotenuse. So sine theta is equal to our opposite side measure, which is 0.371 over 0.495. And so how can I get my theta? We're going to do an operation here. So let me just write this down. Sine theta equals we're going to do the inverse sine operation on both sides of this equation to get our angle. sine and inverse sine by definition cancel out, leaving us with just theta is equal to the inverse sine of this fraction. Make sure your calculator is in radian mode. So inverse sine of this value gets me that. So 0.847 radians. Okay, number 20. So we have a right triangle, and we have our hypotenuse here, and a side measure. We want to find the remaining side measure. So we're going to use the Pythagorean theorem. Right, so c squared is equal to a squared plus b squared. Our legs are a and b, and our hypotenuse is c. So 70.2 squared equals 23.3 squared plus, we'll call this side x, plus x squared. So x is equal to the square root of 70.2 squared minus 23.3 squared. Which means x is going to be equal to 66.2. Okay, so number 26. So Ellie wants to make egg sandwiches, and eggs come by the dozen, so that's 12. And muffins come 8 in a package. What's the fewest number of sandwiches she can make and have no eggs or muffins left over? So imagine like each carton of eggs I buy. So if I buy 1, I have 12. 2, I have 24. 3, I have 36. 4, I get 48, and so on. And each package of muffins comes 8 in a package. So 8, and 16, and 24, and 32, and so on. And we want to know the fewest number of sandwiches she can make and have no eggs or muffins left over. So this answer is going to be the first multiple that they share in common. So 24 is our answer. Really, what this question is, the answer here is just the least common multiple of 8 and 12, which is 24. Because I would buy 3 packages of eggs, no, 2 packages of eggs to get 24, and 3 packages of muffins to get 24. So I use both of these completely, nothing's left over. Okay, 27. So York stands, let's draw this guy. York, he stands 3,500 feet from a demolition site. He sees an explosive detonated at the site, so I guess like a mushroom cloud, an explosion, right? And the sound waves are going to travel at a speed of 343 meters per second. Okay, so what is the time interval between seeing and hearing the explosion? So really this is just another distance equals rate times time question. But again, the units don't match up. We have feet here and meters here. So I'm going to change this unit of feet to meters. The way I'll do that, I'm going to change this measure of feet. I'm going to change it first into inches. There's 12 inches per 1 foot. Then I'm going to change inches to centimeters because there are 2.54 centimeters in 1 inch. And then I'm going to change centimeters to meters. There are 100 centimeters, 1 meter per 100 centimeters. So we get a lot of cancellation here of units. Leaving us the measure of 3,500 feet being equal to 1,066.8 meters. And so now I can use this equation, distance equals rate times time. My distance between this guy and the explosion is this many meters, and it's equal to our rate, this many meters per second, times time in seconds. So I'll just divide here. I get my time is equal to 3.11 seconds. Okay, so we have a gallon of typical house paint covers this many square feet of wall area. I'll highlight it. What is the dried paint coating thickness? You want to know the coating thickness on the wall. If 75% of the paint is solvents which evaporate when drying. So let's kind of contextualize this. So let's say I have like a house. Let's put a door, let's put a window, a chimney, and a smoke. But the main idea is that we're painting this house. It's like, let's say we're painting it blue. It's going to have a very tiny thickness of paint. So thickness right here is what we're solving for. We kind of take this to the third dimension real quick. We know that this paint covers an area, like this bucket of paint, this bucket of blue paint. It's going to cover 400 square feet of wall area. This bucket is 1 gallon. So a gallon, this is another conversion you guys gotta memorize. 1 gallon is equal to 231 cubic inches, and also 1 cubic foot is equal to 7.48 feet, no, 7.48 gallons. So we're going to use this conversion. You could use either and you'll get the answer. We're going to use the second one to help us get the answer. So I have 1 gallon of paint, and I know that I have 1 cubic foot every 7.48 gallons. These units will cancel out. So if I have 1 gallon of paint, I have 1 over 7.48 cubic feet. So I have 0.33 or 0.1337 cubic feet of volume that I'm working with. I also know, because this paint, you could think of it as a very thin, this is not drawn to scale, whoa, technical difficulties. So we could think of this coating of paint as a very thin rectangular prism, right? And the volume of this prism is like base times height times this depth, right? Or length times width times height, whatever you use, right? And we already know what the base times the height is equal to. It says 400 feet squared. And I also know what the volume of paint I'm going to use is. This volume is equal to this many cubic feet. And my area is 400 square feet. My volume is going to be equal to my depth times my area. So now I can solve for my depth. I'll do 0.1337 divided by 400. Now get that my depth is equal to 0.000334 feet. But we wanted our answer in milliinches. And there's still this last fact about 75% of the paint being evaporated when drying. So first, let's change this length in feet to milliinches. I have this many feet. And for every foot I have 12 inches. And a milli-inch, it tells us, milli-inch, like there's 1,000 milli-inches in 1 inch, so I'll write it like this. That's milli-inch per 1 inch. So these units cancel out. These units cancel out. And I'm left with about 4.011 milli-inches of thickness. But 75% of the paint evaporates when drying. It evaporates when drying as said here in this last sentence. So that means only 25% of this paint is going to remain. So I multiply by 0.25 that remains. And I get 1.00 milli-inches of thickness after the paint has dried and 75% has evaporated. So my answer here is 1.00. Okay, number 29. So we have the cylinder and we want the volume. So cylinder's volume is equal to area of the base times height. The area of the base is the area of a circle, which is pi r squared. So the volume is just pi times r squared times h. So pi times my radius, right? My radius is equal to half my diameter. My diameter is 7.87, so I gotta half it to get my radius, so I'll square it. Times my height, 12.6. That's going to give me an answer of 613. And number 30, I know what the total surface area of this rectangular solid is. I have two of the lengths. I have the length and the height, but I don't know what the width is. So the surface area, let's think about what that's going to be equal to. So I'm going to have two surfaces, like if I kind of draw these lines right here to show the other side. I'm going to have two surfaces that have the same exact area. This one and this one on the other side. Right? I'm going to have two surfaces that have the same area on this side and this side. And then again on this bottom base and this top base. So my surface area is going to be equal to 2 times my length times width plus my length times height plus my width times height. It's the area of these three unique surfaces doubled. So I have 400 is equal to 2 times, and this is length, width, and height. Length times width, so that's 16.3 times x. This is my unknown, so x. Plus my length times height, which is 26.3 times 4.38, plus my width times height, so that's 4.38x. And so now I can use my solver to solve for x. So, like this. And it gives me my answer of x equal to 6.22. Okay, so for 36, U.S. gross national income was this many $1 trillion in 2019. I don't think that matters. It was that many $1 trillion in 2019. And the next year, it was $21.69 trillion. And I want to know what the percent increase is. So the way you do percent increase, if you have a first value of A and then a new value of B, the percent increase is going to be B minus A over A times 100. That's your percent increase function. So I could just do 21.69 minus 21 or minus 20.84 over 20.84 times 100. And that gets me an answer of 4.07. I'm going to ignore the SD part for now because I don't know how to do SD questions. Like, technically the answer here officially is 4.1. But we're just going to put 3 sig figs for all of these questions, pretty much. Okay, 37. So Meg runs a mile. So 1 mile in 6 minutes 48 seconds. Right, so that's basically 6 plus 48 over 60 minutes, right? She starts running around this track, this 440 yard track, and at the same time Mary leaves her running the opposite direction. So we have Meg running this direction, and we have Mary running the opposite direction. And they meet up after Meg runs like that many yards. So I can draw this a little better. So if they start here, runs here, and then there. And they meet up right here from their starting position. So Meg ran 260 yards from here to here. You want to know what Mary's speed is. Okay. So first let's find out how long it took Meg to run these 260 yards. So let's change yards to miles, right? Make sure our units are the same. So 260 yards times 1 mile for every 1760 yards. These units cancel out. This is 0.1477 miles. And from this piece of information right here, we're told it takes her 6 and 40 over 60 minutes to run 1 mile. So we'll multiply here. These units cancel out, leaving us with minutes. Getting us 1.0045 minutes. So this is how long it took Meg to run from here to here, which should be the same time it took Meg to run from her starting position to this same location. But Mary ran a different distance. She didn't run 260 yards like Meg did. She ran 440 minus 260 yards. She ran this 180 yards. Because the whole track is 440. So if this part that Meg ran was 260, then this part that Mary ran had to be 180. So Mary ran 180 yards, which I'll just divide by 1760. So she ran 0.1023 miles in the same amount of time. So if this is Mary's time, and this is her distance, we could use distance equals rate times time. But keep in mind, I want my rate in miles per hour. So let's change this time of minutes into hours. So to get minutes to cancel out here, I'll have minutes on the bottom, hours on top. In 1 hour, there's 60 minutes, so 1.0045 times 1 over 60. This is 0.0167 hours. So distance equals rate times time. That's our time, that's our distance. So we're going to do this distance divided by this time. Which gets us 6.11 miles per hour as Mary's speed. Okay, number 38. So lung capacity is 5 liters. It's like 5 liters for every lung. And about 5% of breathed air is converted to carbon dioxide, so CO2. The average respiration rate is 16 breaths per minute. And the world population is this many billion people. So we want to know the daily world production of carbon dioxide from people breathing. So this one's actually pretty easy. So billion we could just represent by this power of 10 to the 9. multiplying by this factor of 10 to the 9. So we have this many people, and each of them have a lung capacity 5 liters per lung. Or not per lung, but like 5 liters per person, I think. So actually, let me rewrite this. We have this many people. We're going to multiply this by 5 liters of air per person. And 5% of that air turns to CO2. It's like CO2 over liters of air. And then we'll multiply this all by a factor of 16 breaths per minute. And then times 60, and then times 24. Because this is breaths per minute, this is how many minutes are in an hour, and how many hours are in one day, because we want our daily production of carbon dioxide. So we're going to multiply all of these numbers together. We get 4.42 times 10 to the 13th power, which is our answer. Okay, so 39, we have a circle and a scaling triangle inscribed in it. So what we're going to do here, the formula to get the radius when you have a circle and some scaling triangle with sides A, B, and C. So to get like this circumscribed circle's radius, R is equal to A times B times C over 4 times the square root of S times S minus A times S minus B times S minus C. And S is equal to the semi-perimeter of the triangle. So it's just the perimeter, and then you divide it by 2. So I have a program for this, so I have to look up the formula right now. Because programs make this question way faster. But here's the formula, just so you know. So first let's get the semi-perimeter. So the semi-perimeter, S, is going to be equal to 0.932 plus 0.637 plus 0.506 over 2. So S is equal to 1.0375. So R is going to be equal to the product of the sides over 4 times the semi-perimeter, and S minus A is going to be 0.1055, and then S minus C is going to be 0.4005, and then S minus A, S minus B, and now we have S minus C, so 5315. So I get my radius is 0.942. 492. I might have misspoken right there. One quick, I guess, special case they sometimes test. Let's say you have some angle like 80 degrees and some side like 12.1, and I want to find the radius. If I'm just given a side and an angle that's opposite to it, then the radius is equal to the side divided by 2 times the sine of the angle. So there's like an extra piece of information in case you see that question pop up. Okay, so number 40. This one's pretty easy. So we have these congruent scalene triangles. So because they're congruent, this angle right here is also 30 degrees. This side is that. And so we're perfectly set up to do the formula for law of cosines. So law of cosines states that if you have sides A and B and C, and you have this angle C, you want to know what C is equal to, then C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of C. Your angle C, right? So to get side C, I'm going to do the square root of 0.208 squared plus 0.636 squared minus 2 times A times B times the cosine of 30 degrees. Make sure you're in degree mode and not in radian mode when you're calculating this. So here our side C is going to be 0.468. Okay, 46. So this question says a violin weighs 1 pound and is 23 inches long. And I want to estimate the weight of a double bass. So I don't know what the weight of the bass is. So I'm going to just put X pounds. If it is 6 feet long, let's change feet to inches. Let's multiply by 12. 72 feet. So 72 inches. 72 inches long. So we're going to set up this proportion, but we can't just solve this proportion for x, because it's not finished yet. Because this top column right here represents three-dimensional entities. This bottom column represents one-dimensional entities. And you can't directly compare 1D entities and 3D entities. They have to be the same dimension so you can do a proportion. And so we're going to change these 1D entities into a 3D entity, to 3D entities by just cubing them. So we cube the bottom. Now we can solve for x. X is equal to 30.7. Okay, 47. So Donnie practices throwing his balls at prescribed distances. So here let's put his desired distance and his actual. Yeah, 15, 30, 45, and 60. And here in the actual we have 12, 35, 55, and 55. And I want to know what the correlation coefficient for this data is, right? Correlation coefficient. So the way we're going to do this, if you have a TI Inspire, you're going to go to this Lists and Spreadsheets page. We're going to call this top column A. We're going to label it X. And then this top column B, we're going to label it Y. So it's going to be our X and Y column. And then, once we get down to row 1, we're just going to fill in all of our data points. Same for the other column. So we have all our data points listed in. Now, we're going to do a linear regression. So we're going to go to Menu. We're going to go to 4 for Statistics, 1 for Stat Calculations, and then 3 for Linear Regression. For our X list, we're going to label it as X, and our Y list, we're going to label it as Y. Click Enter twice, and you're going to get a lot of data here, like your M, which is your slope, your B, which is your y-intercept, your R squared, which is your, I think, coefficient of determination, but we don't really test that in calculator. But R, under R squared, that's going to be your regression coefficient or correlation coefficient. Same thing. And what we get for that is 0.940. About 0.940. So that's our answer. Number 48, we're just going to use our solver. Just do like x times sine of x plus 5x equals cosine of x. Make sure you're in radians. So like that, we get our answer is about 0.189. Okay, 49. So we have congruent isosceles triangles forming an 8-sided solid. We want the volume. Okay, so what we can do here, let's look at just one of these square-based pyramids, because it's two square-based pyramids on top of each other, right? So the square base has a side of 1.81. It's going to have a height of half of the two heights, right? Added together, so 2.96. Okay, so to get the area of a pyramid, it's going to be area of the base times height divided by 3. So that's just side squared times height over 3. So 1.81 squared times 2.96 over 3. So the area of one of the pyramids is 3.23. We gotta double it because there's 2 of them in this problem. So our answer is going to be 6.46. Okay, number 50. We have a hemisphere and a cone. We know what the surface area of this figure is. We know what the radius of the cone and the hemisphere is, but we want the height. Or the combined height of the cone plus the radius, because that's what this whole segment is. The height plus the radius. So let's set this up in a solver. We have 800 being equal to the surface area. So this part right here is going to be half the area, or half the surface area of a sphere. The surface area of a, I almost put square. Surface area of a sphere is equal to 4 pi r squared. We're dealing with half of that. So instead of 4 pi r squared, it's going to be 2 pi r squared. So 2 pi times 8.09 squared. That's going to be, this bottom area. Shown here. And then we need this lateral area of the cone, right? So the lateral surface area of a cone, so like the LSA of a cone, is equal to pi times your radius times your slant height, which I call L. Your slant height is just this length. Your slant height is equal to the square root, your radius squared, plus your height squared. Right? It's because like your radius and your height make a right triangle. So it's like by Pythagorean theorem, this holds true. So this is pi times r squared plus h squared, and you get the square root. So pi times r radius times the square root of 8.09 squared plus h squared. So I'll write this all in my solver, and then solve for x, and I get about 12.98. So h equals 12.98. But keep in mind that's not our answer. This height is the height of our cone. This whole length that it wants, the question wants, is the height of the cone. Right, height of the cone plus our radius. So let's just add them up. 8.9, we get 21.1. Okay, so 56. So what is the slope of the curve y equals 3x times sine of 2x at x equals pi? So this is a bit of calculus. So we have this graph. Looks something like this, and where x equals pi, we want to find what that slope is at this tangent point, tangent line. Okay? There's a pretty easy way of doing this on the end spire. So if you go menu, and you go to the calculus page, so 4, then you go to 2, you can do derivative at a point. Derivative is basically the same thing as your slope. I get this little dialog box that appears. And so my variable is x, and my value is pi, because I want to know when x is equal to pi, what the slope is going to be. So I click enter, and I get this set of text. So I'm just going to enter in my function, so 3 times x times sine of 2 times x, like this. Click enter, and it gives me my answer, just like that. So menu 4, 2 for derivative at a point. So we get 18.8. Okay, so now we have the toughest question on the test, 57. You typically want to save this one for the end every time. So 57 says We have a cylindrical tank on end used for water storage. It is 2 feet in diameter and 8 feet tall. So probably something like this. So 2 feet diameter, 8 feet tall. The drainage rate is proportional to the head, x, and the vertical distance of the water level. Or no, the head is the vertical distance of the water level above the drain. So basically it's instantaneous height. According to this, v dot means dv dx. So the change in volume over change in time. So I'll write that dv dt is equal to negative this times, I'm going to put height instead of x. Now I want to know how long it takes to drain 90% of a full tank. So we have this expression here. Another expression for dv dt that I can derive is, well, let me think about how this is changing. So over time, the water level is going to decrease, right? And so that means that really only the height is changing. The area is going to stay constant. And this is going to change with time. The area is going to be, well, diameter over 2 to get the radius, square times pi. Area is equal to pi. Area of the base. So the volume is going to be equal to pi times whatever the height is. Then I take the derivative of both sides with respect to time. I get dv dt is equal to pi times dh over dt. Also, I'm hoping you guys have some calculus knowledge here, because this one is not a friendly question for beginners. I guess like for more onto like this kind of concept, it's like related rates. So now I have two expressions for dv dt. I can set them equal to each other, so I have pi times dh dt is equal to negative 0.08 times height. And now I can divide both sides by pi times h. The reason is to get the pi to this side and the h to this side. And so I end up with 1 over h dh dt is equal to negative 0.08 over pi. Now I can take the integral of both sides to get rid of this dh dt term. So I'll get ln of h is equal to negative 0.08 pi times time plus c, some constant. And I can raise both sides to the e, or like take e to the power of both sides, which leaves me with h on the left hand side. On the right hand side, by exponent rules, I'm going to call this c1 and end up with some second constant, because this is going to turn into e to this times e to the c1 which this in it of itself is some other constant c2. So c2 times this. So this is my expression for the height at any moment in time, but I need to solve for c2. So let's think what happens when time is equal to 0. When the drain hasn't been opened yet, when t is 0, this whole term right here turns into 1. And so at t equals 0, h is equal to c2. And h should just be the height of the container, which was 8 feet. So c2 has to be 8. And now I have my completed formula. So I want to know how long it takes for 90% of the volume to drain. So that would be like only 10% of its initial height of 8 remains. Set that equal to this, and solve for t. So I'm just setting this up in my solver, so I get 90.4, but that would give me my time in minutes, so I gotta divide it by 60 to get my time in hours, and I get 1.51 as my answer. So that one's a long question. It's a little nasty. So look at all that work. In comparison, this next question's very easy. Number 58. We want to solve for t if the determinant of this 3x3 matrix equals negative 100. So we're going to set up a solver. And inside the solver, I'm going to set up this determinant expression, and then the 3x3 matrix. So I have my solver open. Then I'm going to go to menu, then 7 for matrix and vector. Then I'm going to go to 3 for determinant. And then inside these parentheses, I'm going to go back to menu, because I want to create my 3x3 matrix. So the way I do that is I go to menu, 7 for matrix and vector, 1 for create, and then 1 again for matrix. And so here it's specifying what size matrix I want. So I want a 3x3. Click enter, and just fill out these rows. -3, 32, 5, -3, 5, and 10. It's equal to -100. And I get my answer, -0.253. Okay, so number 59 is kind of like the opposite of 56, where we wanted to find the slope on a curve given its x-coordinate. We want to find the x-coordinate given the slope of the curve at a point. So we're going to set up a solver. So we're going to say 2 is equal to the dy dx 5 sine x cos x for x is equal to some unknown value a, so a being our unknown. So the way I'm going to set that up, so I have my solver, and I'm going to set 2 equal to, and I'm going to open parentheses here. I'm going to go to menu for 2 for derivative at a point. My point is a. I'm going to click enter. So there, and then I'm going to type in my function. So it looks like this. Then I'm going to solve for a, so put comma a at the end, and then I get 4 possible equations here. So I get a is equal to this value times n1 minus, okay, well, plus or minus this. So that's 2 equations right there. Or 6.28 times n2 plus or minus 2.56195. That's like 4 equations right there. Keep in mind there are multiple points where this graph is going to have a slope of 2, because it oscillates, so there's going to be like infinitely many values. Which is why we have these n1 and n2 values. What these mean are basically you can substitute any integer value in for n1 and n2, and it's a solution. So there's going to be a slope of 2 here, here, like kind of like that, and there. So we're looking for the third one after the origin, so after 0, 0. And so when n1 is equal to 0, we get a solution here. That would be 0.5796. When n2 is equal to 0, and look at the positive one, then I'll get 2.56 here. And then when n2 is 1, and I do minus this value, that would be the third smallest possible solution after 0, which would give me 3.72, which is my answer. So this question was kind of annoying because you had to like plug it in like to these different equations and think about what the third solution after 0 would be. So 3.72 is my answer. Okay, number 60, this one's pretty easy. So the rectangle area is equal to the triangle area, so let's draw it out. Whoa, that could have been better. So I'll redraw. That's fine, right? And so the rectangle's area is base times height, right? Base times height. And we're setting that equal to the large triangle's area, which is the same base times a height of 0.0124 over 2. Right, base times height over 2 is the area of a triangle. You can see we could cancel out these bases. So our height of the rectangle, right, it's just going to be this value over 2, so 0.00620. So that one is pretty nice. And now we're on the last few questions. Okay, 61. So in 2021, a 12-box bundle sold for almost $16, assuming annual inflation at 2.6%. What would a single box have sold for in 1900? So I have 12 boxes cost that much. In 2021, the annual inflation rate is 2.6%. So to get what the price of a 12-box bundle, so this is in 2021, to get the price of a 12-box bundle in 1900 is, I'd have to go back 121 years. And given that the annual inflation rate was 2.6%, I'd have to do 15.99 divided by 1.026. Like, this is the factor in which I would divide by to go back a single year due to inflation. But I'm not going back a single year. I'm going back 121 years. So I gotta raise this denominator to the 121st power. So dividing by 1.026 to the 121st power would get me the cost of a 12-box bundle in 1900. So get a very small value here that's equal to 0.716. But I want to know what a single box would sell for, so I gotta divide it by 12. I get about $0.06. 0.06. Okay, 62. So this is an overflow question. So the way we do these, so your first step, you want to take the log of the base. So we're going to do log of the base, which is 53,669. And we're going to multiply by our exponent. So 98,980. And this comes out to 468,148.03235371. And when you're doing this test, you probably want to write this number down on your paper, so like somewhere like here. This part to the left of the decimal point. So you're going to take this away from the answer after you've written it. So you're just going to subtract by that whole numbered part. So you should only be left with the decimal part at this point. You're going to take this decimal part of the equation, and that's, you're going to do 10 raised to this decimal part. So that's going to be about 1.08. And so our answer, we're going to combine two parts here. We're going to combine this part and this number we wrote down. The answer is going to be 1.08 times 10 to the 468,148th power. So this is our power there, and this is our base. So basically the formula always goes log of the base times exponent. Write down the integer part, subtract it from the number, leaving only the decimal part, then do 10 raised to that decimal part, and then that number you get is going to be like the first 3 significant digits, and then the number you wrote down earlier, that integer part of that number we calculated from doing log of the base times the exponent, that's going to be the power of 10 here. Okay, number 63. So Ronald fires a toy motor from the ground that is 25 feet from a 12-foot wall. If it just clears the wall, what's the release angle? So this is a physics question. So there's 2 little shortcuts I like to use. So if it just clears the wall, then when it hits the ground again, it's going to travel a total distance of 50 feet, right? Because it'd be like self-symmetric at that point. So there's 2 formulas to know. So there's the formula for your maximum height in the y, so y max, and your range. I guess I can write range. So your y max is going to be v squared times sine squared theta over 2g, and your range is going to be v squared times sine of 2 theta over g. So let's use these equations to help us out. So what's g, first of all? What are all these variables? So theta is your release angle, v is your velocity, and g is your gravitational constant. Well, g is your gravitational constant. On Earth, g is, in the 2 ways they'll ask, 9.81 meters per second squared, or, this is the same value, 32.174 feet per second squared. So in this case, because we're dealing with units of feet, we're going to use the 32.174. So you got to memorize these. Memorize them. Okay. So our maximum in the y is going to be 12. So it's equal to sine squared theta over 2 times g, which is 32.174. And then we have our range, which is 50, and it's equal to v squared times the sine 2 theta over g, which is 32.174. Like that. And so what we can do here is if I divide these 2 equations, so I divide, then the v squares cancel out. So that removes like this unknown variable that I don't know, right? So I'm left with 12 over 50 is equal to sine squared theta over 2 times 32.174 over sine 2 theta over 32.174. And now I can set this equation in my solver. So 12 over 50 is equal to sine squared over 2 times 32.174 for sine of 2x is 32.174. Make sure you're in degree mode, because we want our angle in degrees. And I get like all these angles, which are all possible solutions. I get like negative 640 something. And so obviously we can't have a negative angle. So I'm going to go to the first answer, which actually kind of makes sense, which is going to be this 43.8. So that's going to be my degree measure. So you got to know these two equations here, memorize them, and your gravitational constants. I think you could also have set up a system of equations to also solve for the velocity, but kind of bypassed that by just dividing the two equations. Okay, 64. So we have a sector and a right triangle. So no, I'm not going to be able to draw this well. So okay, so we have this length as 5.55. We have this angle theta that we were solving for. And so what can we do here? Well, this is my r. So this my radius. I know that r times theta is going to give me 7.18. Given that theta, of course, is in radians. Right? So r times theta gives you that arc length. We also know that, well, we have this right triangle here, theta. This is r, and this is 5.55. Then r times sine of theta equals 5.55. So I have these two equations that relate r and theta. I can actually divide these two equations to get rid of the r term, which I don't know, so that's useful. So I have theta over sine theta equals 7.18 over 5.55. So I go into my solver, make sure you're in radian mode. And I get that theta is equal to 1.21. That's my answer for 64. So you have to know that arc length formula and related to, I guess, like SOHCAHTOA, that triangle part. And the last question, 65. So we want to find this hatched, or we have this hatched area already, my bad. We want to find the side of the square. We have a point going from here to the midpoint to this corner, and line going from corner to corner. And we have these intersection points. So there are many ways to do this question. My personal favorite way is just to do an integral. So what I can do here is, I'm gonna call the side length, I'm gonna call it 1 for now. And then I'll scale it later, and you'll see what I mean by that. Okay, so if the side length's 1, then I'm also going to do this. I'm going to do coordinate geometry here. I'm going to call this point right here the origin. So this line right here, extending from the origin, it's going to have an equation of y equals 2x. Right? Because it travels half a side length, goes up, it goes half a side length, goes up a side length, so rise over run, it's like 2x. This equation right here would be 1 minus x, y equals 1 minus x. And this equation right here would be 1/2, or y equals 1/2 minus 1/2 x. And what I'm going to do is I'm going to graph all of these equations. On my calculator. So it kind of looks like this, right? And I'm going to find the points where these lines intersect. So right there. I just did menu 811 and plotted the intersection points. And so what do these coordinates tell me? Well, let me draw the square here. It tells me this point here was 0.2, 0.4. Right? So, if this whole side length was 1, like we stated earlier, then this length right here, I'm going to write it in blue, that's going to be the side length of the square over 5. Actually, wait. No. I was thinking about doing it the other way. Now, what we can actually do here, given these points, so this was 1/3, 2/3, I'm going to do an integral. So I'm going to split it up into this orange section. And what I was referring to earlier was like this other way of doing it, like with triangles and getting heights and something with similar triangles, but that one's kind of long. I like this way better. So we're going to just do this integral. So the first part, I'll actually write this integral in orange. An integral from 0 to 0.2 of the difference between this line, which was 2x, so this line, and this line, which was 1/2 minus 1/2 x dx. I'm going to add it with the integral from 0.2. Oh wait, no, I need to change these bounds. My bad. So 0.2 to 1 1/3. And this bound from 1/3 to 1. This graph is 1 minus x minus, it's like the difference in this top graph, which is 1 minus x, and this bottom graph, which is 1/2 minus 1/2 x dx. So I'll go back to my calculator page, do menu 4(3) to get my integral. So like that, and I get my area. So the area of this shape is, I'll write it in black. So the area of this shape is going to be 0.1333, just repeating, right? But that's when my side equals 1. In reality, my area, so look, my side is 1, my area was 0.1333, repeating, right? But in reality, my area was 90.2. So what's my side? So what's x? Well, this has turned into a sizing question now. This top part right here, these represent the lengths, which are 1D entities. This bottom part, which represents the areas, they're 2D entities. So if I square these, they're both 2D. Now I can draw a comparison. So from there, I get that my area is, oh, I squared the wrong thing. So from there, I get my area is 26.0. 26.0. So let me talk about the other way I said of doing this question. Right? So the other way I could have done this question was like if I broke it up into parts. So I would have this triangle right here. Okay, so I'd actually have this triangle right here. So this has a height of s, right? And a base of s over 2. And I would be subtracting from it. I want to get rid of this part right here. I want to get rid of it. So the way I do that, to get that part, I'd have to get like this triangle here, subtract this top triangle, and then subtract this bottom triangle, which that leaves me with that like almost trapezoidal quadrilateral piece, which I would subtract from here, leaving me with just this area that I want. And so this is s over 2, this is s. This is s over 2. This is s. This height is a right triangle. This height right here, looking at this height, it's going to be 1/3 s. And why? Well, when we graphed like this whole mess right here, we found if the side length was 1 and this y-coordinate was 2/3, the distance from here to here is 1/3 of the side length, so s over 3. And the base is s over 2. You can also like figure it out using like similar triangles, like this triangle like right here, and this triangle. Sometimes similar triangles are tough to work with. And then to get this triangle, well, I use the same thing. Like this coordinate here is 0.2, so that means this height was s over 5, as a fifth of the height. And this base was s over 2. And so I could set 90.2 equal to like s squared over 4 minus, parentheses, s squared over, well, 4 again, but minus s squared over 8? No, s squared over 12 minus s squared over 20. And then I could have just solved directly for s. This is, I guess, is like the non-calculus way of doing it. I think it's a little longer. And yeah, it would have gotten us the same answer, so. Yep. I mean, I guess we could have just like gone without this. I don't know, like these are the same. I think there's probably some cancellation I'm missing out on right there, but whatever. That's the test. So yeah, that's all of the word and geo questions from the 22C test. If you guys have any questions, leave them in the comments below. If you have a better way of doing any of these questions, feel free to share in the comments for me and for everyone else watching the video. And I'll see you guys later.